All right, here we are. This is the introduction to vectors, and what we're doing is we're looking at how vectors can add. And what I want you to do first is watch the vector video that I posted on the plan. It takes you to a YouTube video that explains vectors in general and how we specify directions and what vectors are. So we'll start here with this little worksheet. We have two vectors. A is a vector that has a length of 3 newtons. That means it's a force vector. That N stands for force. Vector B is another force vector. It is a little bit stronger force. It has a force of 4 newtons. And I have not yet specified the directions of these two vectors. What I want you to get the idea here is that we can draw these two vectors in certain directions to end up with a new vector, A plus B, such that it can have different magnitudes. So for example, if I push in exactly the same direction, 3 newtons and 4 newtons, in other words, if vector A and vector B are both pointing the same direction, then I get a resultant vector, A plus B, which is a length of 7. And we notice that this vector in red is our new vector, which is A plus B. Vectors are showing length to show the magnitude, so that one needs to be a little bit longer in terms of it being a 7 versus this length being a 3 and this length being a 4. So that's how a 3 and a 4 vector could add up to be a 7 vector if they're pointing in the same direction. But what if they're pointing in opposite directions? If they're pointing in opposite directions, then the resultant length will be 1. So in part B here, we're looking at if I take this vector that was 4 long and point it, say, to the east, and then I take vector that's 3 long and point it to the west, when I add those vectors, I put the tail of one vector on the head of the other vector. And so this is the 4 plus the 3. And then our resultant we look at from the beginning to our end. So our 1 Newton vector here is only 1 long. And that's a 3 plus a 4 vector will give us a vector of 1 if they're pointing in opposite directions. So a 3 vector plus a 4 vector can give us lots of answers depending on what directions they're going. What if they're normal to each other? What if they're perpendicular to each other? So let's take a look at that. That's on C. So what if I have the 4 Newton vector pointing, say, east, and the 3 Newton vector pointing south? Then we get a new vector that's 5 long. This is a 90-degree triangle, and you've probably heard of a 3, 4, 5 triangle before, but this will give us a vector that's 5 long if our 4 and our 3 are at 90 degrees to each other. And in fact, you can think about this 3 vector pointing in lots of different directions, and you can get lots of different lengths for A plus B. You can get A plus B being any length essentially between 1 and 7, depending on the angle between your vectors, how they add up. You can get 4, for example. So here's the 4 vector plus the 3 vector in red. So here's our 4 vector plus our 3 vector. We know we're adding them because if this one goes tail to the head of the vector, the arrow is called the head of the vector. So we go, this one is east. This one is pointing down south and west. And we can see that its length is 3 long and its direction is to the southwest. The head is down here, the tail is up here. We're adding these two red vectors by putting the tail of one vector on the head of the other vector. We can just move those vectors around until we make a triangle. The resultant of adding that 4 and that 3 is marked in blue here. We put the tail at the very beginning, we put the head at the end of our addition. And sure enough, we can do an isosceles triangle here so that the length of our resultant vector, the addition of the two red ones, is indeed 4 long. And so that's how we do number 1. And I'll have some other screencasts on the other one. Hope that's helping a little bit. Watch that earlier YouTube video if this is still feeling a bit tricky for you. Thanks a lot.